Hello and welcome to my channel. In this video, I will show you how to blink an LED using an STM32 microcontroller. We will go through the basic setup, the code, and how to get your LED blinking. Let's dive in. To get started, we will be using STM32 Cube IDE. First, create a new project and select your specific MCU. This window shows the pinout view of the microcontroller. I will choose GPIO B pin 7 to drive my LED. Click on it and set it as GPIO output. If you are using a different STM32 development board, be sure to check your board's datasheet or pinout diagram to find out which pin corresponds to the LED. Now click on this button to create the basic structure for us. Let's take a look at the generated code. Here is the main, and the first line is HAL init that initializes the HAL library. The system clock config that handles the configuration of the clock for the microcontroller, and the MX GPIO init that initializes the GPIO. We'll take a look at the definition of this function. To enable a GPIO, we first need to enable its clock. This is done by calling this function for GPIO B, and then call this function HAL GPIO init. This function takes two input, GPIO port and address of a variable of type GPIO init type def. We should declare this variable and initialize it. This is an struct that contains four members: the pin, the pin number of selected GPIO, the mode, operating mode for the selected pins, could be input mode, output push-pull, and etc. We want to drive a LED, so we use GPIO output push-pull. The pull for pull-up, pull-down, or no pull, and the speed that specifies the speed. This is not important for us, so we choose the lowest one. And to control the LED state, we use two functions, HAL GPIO write pin and HAL GPIO toggle pin. The HAL GPIO write pin set the pin state to either high for LED on or low for LED off and takes three input: GPIO port, GPIO pin number, and the pin state. And HAL GPIO toggle pin flips the pin state of the GPIO pin and takes the GPIO port and the GPIO pin number. In the MX GPIO init function, the variable of type GPIO init type def declared here, and then enable the clock of the GPIO B port. And in the next line, using this function HAL GPIO write pin, we set the initial state of the GPIO pin 7 to GPIO pin reset, and then initialize the variable of GPIO init struct members. And finally, by calling this function HAL GPIO init, we can initialize our GPIO pin. Now we move to the infinite loop in main. This is where we control the LED. And by using this function, we toggle the LED state. And the HAL delay. This function introduces a delay. It's important because without it, the LED would blink too fast and we can't see it. Okay, let's program the microcontroller and examine the code. Now let's add another LED to our project. We can reuse the same GPIO init type def struct, but this time we will change the pin number to match the second LED. I choose the pin number 6. So I change it here. Don't forget to double check your board's pinout diagram if you are using a different STM32 board to make sure you're selecting the right pin. After initializing the second LED with another call to HAL GPIO init, I want to toggle the LEDs in a way that only one of them is on at any given time. For that, we start by setting one of them to on and another one to off. This is done by using Hall GPIO write pin. I set one of them to on and another one off. In the infinite loop, we toggle both LEDs using Hall GPIO toggle pin. This function flips the state of the pins, turning them on or off each time it's called. To make both LED blink alternately, we will use the OR operand to toggle both at the same time here. Okay, I will program my microcontroller and see what is happening.